This is Robert Leduc, and today I'm going to review challenge activity 7.2.1, indicate Z's value over time. And in this activity, we're going to be given a high-level state machine, and we're also going to be given a timing diagram showing the clock cycles and a value for the input A, and our job is to determine, given this information, what the corresponding value of the output Z is. So if we look at the first problem here, we see that we are given a high-level state machine with two states, reset and increment. And before the first rising edge of the clock cycle, we are going to be in the initial state, which is the reset state. And in the reset state, we see that variable I is given a value of 0. And since the output Z is set equal to I, we know that Z will have a value of 0 as well. When we have the first rising edge of the clock, we see that the value of input A is 0. And according to the diagram, when A is 0 or false, we will continue to cycle back to the reset state. So since the value of Z in the reset state is 0, we're going to continue to have a 0 value for Z all the way until the rising edge of our last clock cycle here. We have a value of A that is 1, and according to the diagram, when input A is 1, we transition from the reset state to the increment state. And in the increment state, variable I is incremented by 3. So I will have a value of 3, and since output Z is set equal to I, Z will also have a value of 3. And that's it for this timing diagram, so we'll go ahead and check our answer, and that is correct. So that wasn't too bad. We'll move on to the next one. And here we have essentially the same high-level state machine with a slightly different timing diagram. So again, with our first clock cycle before the first rising edge, we know we're going to be in the initial state, which is the reset state. And just like in the previous example, I is set to 0 and Z is set to I. So our first two values will be 0. On the first rising edge, A is low. It's 0. So in this case, just like in the previous case, when A is false, we will cycle back to the same reset state. So the values of I and Z will not change. So for this clock cycle here, the value of output Z will remain 0. For the next rising edge of the clock cycle, the value of A is 1. And according to the diagram, when A is 1, we will transition from the reset state to the increment state. And in the increment state, we will increment the value of variable I by 3. And since Z is equal to I, the value of output Z will be 3. And that will persist for one full clock cycle until the next rising edge, when we see that the value of input A has gone back to 0. And according to the diagram, this will transition us back to the reset state. And in the reset state, the value of I is set back to 0. And since Z equals I, the value of our output will be 0 as well. So if we check our answer, looks like that's correct. So moving on to the next one. Again, pretty much the same high-level state machine. Here, we're going to start in the reset state. Initial value of I is 0, and with z equals I, the value of our input before the first rising clock edge is 0. Upon the first rising clock edge, we see the value of our input A is 1, which will transition us from the reset state to the increment state, which will increment the value of I by 3, which gives it a value of 3. And since output z is equal to I, our z value will be 3 for the full clock cycle. On the next rising edge of the clock cycle, we see that A is still 1. And according to the diagram, a value of 1 for the input will cycle us back to the state where we're already currently in, which is the increment state. So we will perform the increment function again. So since the current value of I is 3, we will add 3 to that, which will change the value of I to 6. And since z is equal to I, our new value of z is 6. And that will persist for a full clock cycle until the next and final rising edge of the clock, where we find the value of A has gone back down to 0, which takes us back to the reset state, where z, the value of z, returns to its initial value of 0. Checking our answer, we are correct. And moving on to the fourth problem, we see we're given a slightly more complex high-level state machine here. In addition to a start and increment states, we also have a decrement state. So we see that, again, for our initial 2 values of z, we have not reached our first rising edge yet, so we're going to be in the initial state, which is the start state. In this state, we're told that the value of variable I is 50. And since z equals I, the value of our output z will be 50 as well. Okay, and then on the next rising edge, we see that the value of A has risen to 1. And interestingly, if you look at the diagram, it actually doesn't matter what the value of A is, because here we just have a single arrow going right. So in this case, regardless of the input, we will always move on the first clock cycle from the first state, the start state, to the next state, which is the increment state. So in the increment state, we see that the value of I is incremented by 1. And since we started with a value of 50, the value of I is now 51. And since z continues to equal I, our new output value z is 51. Until the next rising edge of our clock, we see that the value of A has gone back down to 0. And according to the diagram, a value of 0 for A, or not A, right? So the exclamation point before the A means not A. We're going to transition from the increment state to the decrement state. And in the decrement state, we're going to take the current value of I, which is 51, subtract 2, which will give us 49, and that is going to be set equal to, and then the output z is going to be set equal to that variable, so that value will also be 49. Until we get to our final rising edge of the clock, in which A again goes to 1, and from the decrement state, a value of 1 for A takes us back to the increment state, where we will increment I by 1. Since the current value is 49, that'll give us a new value of 50, which will then become our output Z. So we'll give Z a value of 50, and then checking our answer, we are correct. Okay, for the fifth problem, similar, I don't think it's identical, but similar high-level state machine here. We're going to, again, start off in the start state with an initial value of I of 50, and our output Z being set equal to I. So before the first rising edge, Z will start out with a value of 50. Then at the first rising edge, like we saw in the previous diagram, it doesn't really matter what the value of our input A is. We're going to transition to the next state, which is increment, either way. So in this case, since the current value of I is 50, we're going to increment that by 1, and then we're going to set our output equal to the new value of I, and that's going to be 51 for the duration of this clock cycle until the next rising edge. And we see here that the value of A in this case is now 0, and according to the diagram, this not A arrow will transition us over to the decrement state. And in the decrement state, we're going to take the current value of I, which is 51, and subtract 2, which will give us a value of 49. And then, again, we are going to set our output Z equal to I, so the value of Z becomes 49. And then once we reach our last rising edge of the clock cycle, we see A has returned to having a value of 1. And according to the diagram, when we are in the decrement state, which we are now, a value of 1 for the input will take us back to the increment state, in which we will take the current value of I, which is 49, add 1, which will give us a value of 50, and then the output Z is set equal to that value. So here our output becomes 50. Now we'll check our answer, and looks like we're correct. All right, and this is the last problem in the challenge activity, and here again we see a similar high-level state machine, and we're going to start in the pretty much the same place with the same value of I being set to 50 and Z being set equal to I. So prior to the first rising edge of the clock cycle, in the start state, Z will have a value of 50. Then, regardless of the value of A, we are always going to transition to the increment state, in which the current value of I 50, or I should say the previous value of I 50, will be incremented by 1, so that the new value of I is 51, which is becomes our output. So Z is now equal to 51 for a full clock cycle. At the next rising edge of the clock, we see that the value of A has now risen to 1. According to the diagram, when the value of input A is 1 and we are in the increment state, we just cycle right back to the increment state and repeat the function for I, which is to increment the value by 1. So since the current value is 51, the new value will be 51 plus 1, which is 52. And the output Z, will, being set equal to I, will have a value of 52 for a full clock cycle And then for the final rising edge, the value of A is still 1. So we will repeat that same function again, cycling back to the increment state. We will increment I, which is currently 52. Adding 1 to that will give us a new value of 53, and setting our output Z to I gives us an output value of 53. Then when we check our answer, looks like we were correct on that one as well. So that's it. That's all 6 problems in this challenge activity. Thanks for watching.